right, so we want to find the measure of each angle, and we want to write the reasoning for each of the answers. So let's start with angle 1. So this is angle 1 right here. Angle 1, and notice that angle 1 and angle 58, they are related to each other. We have two lines that are parallel to each other. And how do we know they're parallel? Because the couple of arrows they're giving us. So parallel there, and we have a transversal coming through, so we know that we can use all the characteristics and rules of the parallel lines with their angles. So angle 1 and angle 58, they are corresponding angles, so that's 58 degrees corresponding angles. Very good. Angle 2, we can find angle 3 first before angle 2, which just makes it easier because angle 3 is part of this triangle. Okay, so now we have this triangle right here. So angle 1, 3, and 24, they have to add up to 180 degrees. Okay, angle 3 is 98 degrees. Very good. We still have the two parallel lines, and this time the transversal is this one. So angle 2 and angle 24, they are alternate interior. So this angle here and this angle there, or sometimes some of the books they call them the Z rule. So angle 2 is 24 degrees, and we call it alternate interior angles. Okay, angle 4, now we have another triangle, and the angle that we're going to use, the triangle that we're going to use is this triangle. And in that triangle, we have isosceles triangle because these two sides are equal to each other, and if they are, their opposite angle to each equal sides are equal to each other. Therefore, angle 4 is 58 degrees. And this is the properties of isosceles triangle. Excellent. And then by extension, angle 5, which is right here, is part of this triangle. So all the angles have to add up to 180, and 258, and then 116 minus take away 180, so that would be 64 degrees. And this is the sum of all angles in a triangle equals to 180. And this little sigma notation is sum. This is the angle notation. Triangle is a triangle. It's a shortcut, and that's 180 degrees. Angle 6 basically is a vertically opposite to angle 5. That's 64 degrees. So that's vertically opposite angles. They're equal to each other. And once we have that, that's done. Angle 7. So angle 7 and angle 5, they are alternate interior angles. Now we're going to look at this line and this line. These two lines are parallel, and we have transversal going through. So in this case, angle 5, angle 7, they're equal to each other. And in this case, that's also 64 degrees, and we call that alternate interior angles. All right. For angle 8, the triangle that we're going to look at is this one. Okay, so all the interior angle of this triangle equal to 180, angle 45, plus angle 7 plus angle 8. Okay, and we already know that angle 7 is 64 degrees. We add 64 plus 45, that is 109. Take away from 180, that would be 71 degrees. I hope I did the math right. 71 degrees. And the last question to use again, these are the two parallel lines. We have a transversal coming this way now. It turns out that this angle and this angle, those are the interior angles on the same side of a transversal, one side of a transversal on the left side, they have to add up to 180 degrees. Angle 9 and angle 8, they have to add up to 180. So therefore, angle 9 has to be 109 degrees, because together, 79 plus 109, that will give you 109 degrees. So this is angles on the same side of transversal add up to 180. Okay, that is it.